All right, everybody, what is going on? Here for another video, some more integrals, and this time we're going to look at the exponential form. So these problems, they're going to be e raised to a power. All right, so the antiderivative, or if you integrate e to the u with respect to u, that's just e to the u plus c. So what we have to do is all the problems that we work is we need to try to get the problem, just looking at this first problem, we've got to get this problem to look like this, okay, before we can integrate it. All right, so what do you think we're going to let u equal? Well, the exponent, right? We're going to let u equal this exponent. And then when we take the derivative of the exponent, when we find du, that has to be what's outside, what's over here. So we can see real quick that the derivative of x squared is 2x, right? Well, we have the x, we just don't have the 2. All right, so all this u substitution that we've been doing throughout all of these videos, throughout the course, we can handle that. We can handle there not being a 2 there. We know how to deal with that. So let's go ahead and work this first problem. We're going to let u equal our exponent. And so du is 2x dx. All right. So obviously the x squared is going to be replaced by u. But now let's look at this. You see the x dx? There's the x dx. What are we missing? We're missing the 2. So we can multiply by 2, then that means we have to come out here and multiply by a half. Okay? You can't just multiply by 2. The only number we can multiply by is 1. And that's why we multiply by 2, and then we come out here and multiply by a half. What's 1/2 times 2? It's 1. Okay? All right, so let's make our substitution. So that's going to be 1/2 integral. Now I've got e to the u. I replace the x squared with u, and then the 2x dx, see the 2x dx, I'm going to replace all that with du. And you can see now that this looks just like this. So my answer is 1/2 e to the u plus c. And then I have to take the x squared, plug it back in for u. So that's going to be 1/2 e raised to the x squared plus c. And there's my answer. So it's not difficult to do. You're going to let, if you have e to a power, try letting u equal the exponent. Okay? All right, what about this one? Well, the problem we have here is the e to a power is in the denominator. Our formula does not show e in the denominator. You see that? It's not in the denominator. So we have to first rewrite this. We can write it as e to the negative 3x dx. So all I did is I moved it into the numerator. And remember, when you move something across the fraction bar, it changes the sign of the exponent. All right, so now what are we going to let u equal? Well, u is equal to negative 3x, the exponent. And so now I have du, well, the derivative of this is negative 3 dx. All right, so you can see the only thing I have here is the dx. I need the negative 3. So I got to multiply by negative 3 and then I come out here and multiply by negative 1/3. And so now we can make our substitution, negative 1/3 integral. Now the negative 3x, I'm going to replace that with u, and then the negative 3 dx, see, negative 3 dx, that's du. And so now I get negative 1/3 e to the u plus c, and then I have to take the negative 3x, put it back in the place of u, so that's going to be negative 1/3 e to the negative 3x plus c. And there's your answer. All right. So far, pretty easy, not bad. Oh goodness, let's look at this one. We got a lot going on here, don't we? I've got e's everywhere, don't I? But remember, our main goal, if we can, is just to get it as e raised to a power. Okay? E raised to a power. Now, if you remember in the past, okay, in past videos or past lectures, you might have had something like this. All right. And how did we integrate something like that? Well, what did we do? We would split it up, wouldn't we? You see that? We would split it up, and then we could just integrate this right here. That would become x squared. This would become x. And then we were able to integrate using the power rule. Okay? Well, let's see if something like that would work with this problem. Okay? So maybe I'm going to rewrite this as 4e to the 3x over e to the x plus 1 minus, got the minus here, 3e to the x over e to the x plus 1 dx. All right. Now, we still, like for this term, we still have an e in the numerator, e in the denominator, and same thing over here. So we need to see if we can't simplify that even more. Well, what happens when we have a fraction or division and we have like bases? What do? Well, you subtract exponents, right? It would be e to the 3x minus x plus 1. Don't forget to put the x plus 1 in parentheses because it's minus the whole thing. And then I have minus 3, and that's going to be e to the x minus the x plus 1. All right. So, I mean, right now we're not even integrating this thing. What are we doing? We're just rewriting it so we can integrate it. And so we're going to have the integral 4e. So I've got 3x minus x is 2x. And then I distribute the minus 1. That's going to be minus 1. Minus, and that's going to be 3e. X minus x is 0. And distribute the negative. That's just going to be e to the negative 1. All right. Now, what do we need to do? What do we need to do here? Well, I'm gonna need to use u substitution on this one. This one I don't need to use u substitution. So let's split them up. Okay. So this is going to be, and I'm going to bring the 4 out. Integral e to the 2x minus 1 dx minus, and then this is going to be the integral 3e to the negative 1 dx. All right, so let's use u substitution on this part. So I'm going to let u equal 2x minus 1 du is 2 dx. All right. So you can see I've got the dx here. I'm missing the 2, so I'm going to multiply by 2. So that means I'll come out here and divide by 2. And so this is going to give me 2 integral, and then I make my substitutions. That's e to the u, and then the 2 dx is going to be replaced with du minus the integral 3e to the negative 1 dx. And so this is going to be 2e to the u, integrate that, minus 3e to the negative 1 x plus c. All right, so the wheels in your head might be turning right now. What in the world happened right here? Well, look at this, 3e to the negative 1. What's e to the negative 1? Well, punch it in your calculator. Let's see, e to the negative 1 is 0.367879441. It's a number. And what is that number times 3? See, if I do e to the negative 1 times 3, so times 3 comes out to be, see, this right here is just the number 1.103638324. That's all that is a number. Okay? So let me ask you this. What's the antiderivative of 5? It's 5x. What's the antiderivative of negative 2? Negative 2x. What's the antiderivative of square root of 3? Square root of 3x. Right? Remember how to do that. So this is just a number, so what's the antiderivative of it? E to the negative 1 times x. All right? All right, so now we have 2, and then we have to take the 2x minus 1 and put it back in for u. So that's e to the 2x minus 1 minus, now what I'm going to do here is this e to the negative 1, I'm going to write it with a positive exponent. So I'm going to bring it to the denominator, x plus c. And there's your answer. So, you know, not bad. Not bad at all. All right, so yeah, this one was a little more involved. You had to do a lot of rewriting, and then this right here is usually what confuses students, gets them, you know, that's usually what gets the students. But you've got to understand that that's just a number. That's all it is. It's a constant. Okay? All right. All right, so how about this one? It says for an electric circuit containing a direct voltage source E, a resistance R, and an inductance L, the current I and time t are related by I times e raised to the RT over L equals E over L times the integral e to the RT over L dt. If I equals 0 for t equals 0, perform the integration and then solve for I as a function of t. All right, so let's just go ahead and just write this down. So that's I. Let me change colors real quick. That's going to be I e to the R over L t. I know in the problem. I know in the problem I have the t up there with the r. I like it. If I have a constant, I just like writing it out to the side of the variable. That's no big deal if you write it like this. Okay, same thing. And that equals e over L times the integral e to the R over L t dt. All right, so well, let's integrate this thing. So that's going to give me, let's see, I'm going to let u equal R over L t. So du is equal to R over L dt. So obviously, the r over lt, I'm going to replace that with u. And then look at this. All I have right now is dt. I'm missing this r over l. So I need to multiply by r over l. So that means I need to come out here and multiply by the reciprocal. And so this is going to give me IE to the r over lt is equal to, well, the l's cancel. That's going to be E over r times the integral e to the u du. Okay, so all I did is I made my substitutions. All right, the r over l dt, r over l dt is, replace that with du. And so I've got IE r over l t is equal to e over r e to the u plus c. So IE to the r over lt is equal to e over r e, and now I got to put this back in the place of u. So that's r over l t plus c. All right, yeah, I think I got plenty of room to work. All right. So, are we able to figure out what c is? Let's take a look at that. Yeah, because it tells me if I plug 0 in for t, I is equal to 0. So let's do that. So I've got 0. I'm plugging 0 in for I and 0 in for t. So I've got 0 times r over l times 0 equals e over r e to the r over l times 0 plus c. Okay, that's what it gives me. Now this over here is 0. 0 times that. Now remember, this is e to the 0. 0 times r over l is 0, so e to the 0 is 1. And 1 times e over r is just e over r plus c. So this tells me c is equal to negative e over r. So what does that tell me? That tells me that IE to the r over lt. Now I'm looking at this right here. I'm looking at this part right here. Okay, I'm going to take this negative e over r and plug it in for c. And so that's going to be e over r e to the r over lt minus e over r. Now, what did it want us to do? It wanted us to then solve for I. So I need to multiply everything by 1 over e to the r over lt. So that's going to give me I is equal to, because it cancels out here, right? And it's going to cancel this one out also. That's e over r minus e over r times 1 over e to the r over lt. And then I'll rewrite it, I equals. Now, well, let's just go ahead and do a couple of steps here. E to the negative r over lt. I just moved this up to the numerator is all I did. And then, I mean, let's go ahead and factor that out. I equals e over r times 1 minus e to the negative r over lt. And there's your answer. All right. So, you know, that problem was a little more involved. I mean, we still did the same thing. I mean, basically all we did is we did u substitution. We let u equal the exponent. The only difference is we had variables everywhere. Okay, that's the only difference. But it's all still worked the same. All right, so let's take a look at this one. I believe this is the last problem. It says find the equation of the curve for which dy dx is equal to e to the square root of x plus 1 over the square root of x plus 1 if the curve passes through 0, 1. All right, so typically what we do is we let u equal the exponent, right, if we have e to a power. Okay, and then remember the derivative of that needs to be outside. So we know that y, there's dy dx, so y is equal to the integral e to the square root x plus 1 over the square root of x plus 1 dx. All right, so that's what we have to solve. So we had a problem similar to this. I mean, it wasn't an exponent, it was a natural log. But remember, we had a problem like this earlier. Okay? And remember, the derivative of natural log x is 1 over x. And do you remember, if you watched that video, how I rewrote that as natural log of x times 1 over x? So we could actually see the 1 over x. Well, I'm going to do the same thing with this one. I'm going to rewrite this one as e to the square root of x plus 1 times 1 over the square root of x plus 1 dx. Okay? So we can see that. All right. So let's let u equal the exponent. So u equals the square root of x plus 1, and then du is equal to, so it's the derivative of that. Now, you know, you can take the x plus the square root of x plus 1 and write it like that, do the chain rule to find the derivative. But if you've been watching my videos, you know there's a shortcut for finding the derivative of a square root. And if you haven't been watching my video, I'm going to show you. I have a video just on that. Short. You can Google my channel. Google my channel. Just type in the search on my channel, shortcut for finding the derivative of a square root, and it goes into it. It shows you how to do it. But basically all it is, we're taking the derivative of a square root. You always put this in the denominator, 2 times whatever the square root is. And then what goes in the numerator? Well, the derivative of what's underneath the square root. So what's the derivative of x plus 1? It's 1. And then I've got the dx. Okay? So what am I missing? I'm missing a 2 right here. And that 2 is in the denominator. So it would be like we're multiplying by a half, right? If the 2 were down here. So if I multiply by a half, that means I have to come in here and multiply by 2. Or come outside and multiply by 2, multiply by the reciprocal. And so now I get y equals, and that's going to be that's going to be 2 times the integral. And so that's going to be e to the u. See, the square root of x plus 1, that's going to be replaced with u. And then look at this, 1/2 that dx, that's all of this, that's going to be replaced with du. And so now I've got y is equal to 2e to the u plus c. And then I make my substitution back, put this in for square root of x. Plug the, square root of x plus 1 gets put in for u. So that's going to be y equals 2e to the square root of x plus 1 plus c. Now, what are they wanting us to find? What are they wanting us to find? They're wanting us to find the equation of the curve. And they tell us it passes through this point. So they tell us it passes through the point 0, 1. So remember, that's your x value, that's your y value. So let's plug it in. So I'm going to do 1 equals 2 e square root of 0 plus 1 plus c. And so this gives me, let's see, 1 equals, now what is this? That's 0 plus 1 is 1, square root of 1 is 1, that's e to the first, so that's 2e plus c. All right, so that's going to tell me c is 1 minus 2e if I move the 2e over. So that's c. So let's take this and plug it in, well, not right there. Let's plug it in for c. And so I get y equals 2e to the square root of x plus 1 plus c, which is 1 minus 2e. And there is your answer. And that was actually the last problem. So I hope that video helped. Just remember, e to a power, try letting u equal the exponent to do your u substitution. All right, so hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.